In this question, some garden lights need to come on, and we've been given a circuit down here and a graph here, and just we need to make sure we know what this graph's for. It's for an LDR. So this graph is for the LDR, which is light dependent resistor. That's there. Okay, so this goes with this graph over here. Now the question's on the next page. I've just copied and pasted it onto this page so we can do it all on one page. So the switching circuit turns on when V out here is 4 volts. So when this measures across this LDR, when it measures 4 volts, this thing turns on. So what must the value, the Ryan wants the lights to come on when the illumination has fallen to 10 lux. What must be the value of resistor R here, question mark, so that it comes on at 10 lux. Alright, when we're doing this question, I want you guys to, we'll draw another circuit here as part of our working. Just drawn this part again. Now, we know this is 4 volts, because it says so in the question. The circuit has 12 volts total. That leaves how much for R? Well, if it's 12 volts total, 4 volts is used up here, there's 8 volts left. 8 volts for R. Now before we even get onto the resistance, look at the ratio between this. 4 volts to 8 volts. 4 volts is half of 8 volts. Okay, it's going to help us out quite a lot. Now, the 10 lux, what does that actually mean? Well, if we go to the graph, at 10 lux, the illumination, that's how bright something is this point here. And 10 lux, according to this, is 10 to the 4. 10 to the 4 is 10,000 ohms. So we can write that on our circuit because it's helpful information. Remember, this is the LDR. 10,000 ohms goes beside our LDR. We can write it here, or we can write it here as well. 10,000 ohms. Now the answer to this is really quite easy now. The same ratio here, 4 to 8, is the same as the ratio here, 10,000 to 20,000. Okay, 4 double is 8, 10,000 double is 20,000. The working for that, to make sure we've got everything, is the formula is V out equals R out over R total times V total. Now rearrange that and you get V out over V total equals R out over R total. So then you're working, as you see here, V out, which is this 4 volts, divided by V total, which is 12 volts, is the same as the ratio R out, which is 10,000, divided by R total, which in this case is 30,000. So then you can just write ratios are the same, because they are, and that's how we got this thing here. So I'm just going to put it down here. That's our last little bit of working. Therefore, ratios between V and R are same. And then we'll put our answer, 20,000 in here. Question 6. Alright, question 7. As the sunset approaches, the daylight gets less bright. So as sunset approaches, the daylight gets less bright. Does the value of V out increase or decrease as it approaches 4 volts? Explain your reasoning. So I'm going to leave my answer here because I don't know what it is yet, but I'm going to go through my reasoning first because that's going to help me get my answer. So here's where I'm going to write either increase or decrease. In fact, we can write it both here now, so we know what the answer is going to look like. And I'm just going to cross one of them out once I've done my reasoning. Alright, as the daylight gets less bright, so as it's say 3 o'clock in the afternoon, it's nice and bright, the illumination might be 1,000. And then it gets less bright, it goes towards 100, and then it gets less bright again, it goes towards 10. So as it gets less bright, from here to here, what's happening to the resistance? As it gets less bright, the resistance is increasing. And this is, I've copied and pasted the diagram, the resistance of the LDR is increasing. As it gets less bright, the resistance of LDR is increasing. Now what does that tell us about the voltage, the V out? So this is the V out here. We can use this formula we've always used. V out equals R out over R total times V total. Okay, and R out is the resistance of the LDR. Well, this is the output that we're measuring. So this is R out, just so you remember. And this is just the resistance of the other guy. So as R out gets bigger, obviously V out's going to get bigger as well according to this equation. So as R out increases, so does V out. So the answer is increase. We can cross out decrease there. Alright, last one in this set of questions. Ryan decides he wants the lights to come on earlier. Should he increase or decrease the resistance R to achieve this? Explain your answer. Same as before, I'm going to write, the answer is obviously going to be increase or decrease. I'm going to write them both down so we know what our answer looks like. And then I'm going to work through the working to find out what the answer is and then cross one of them out. So he wants the lights to come on earlier. The way I like doing this type of question is I actually pick a number he wants the lights to come on at. So let's say he wants the lights to come on at, this mark here is 1,100, no sorry, this is a logarithmic scale. So if that's 100 lux, that's 1,000 lux, that's 200 lux here. And that I picked that because it corresponds nicely to a nice round number, 1,000 ohms. So what I write for this one is I assume he wants lights on earlier, say at 200 lux, and in that case the resistance of the LDR equals 1,000, which is just what I read off the graph then, 1,000 ohms. This makes it easier to pick an actual value because you can just do the calculations you did in question 6. You just do the same calculations. It's much easier once you pick the value for it. So assume he wants it on at earlier, say 200 lux. So if I was to draw everything in here, that's 1,000 ohms. We know that still has to turn on at 4 volts, that still has to turn on at 8 volts. So this same ratios, 4 times 2 is 8, 1,000 times 2 is 2,000. Now compared before, when we did question 6, the answer for R, it was 20,000. So compared to that, we've got 2,000, it's much less, so it's going to decrease R. So that'll be the answer. We'll just make sure we've got our work in there as well, decrease R. Assuming he wants the lights on earlier, say at 200 lux, which is R equals 1,000 ohms, to maintain voltage ratios. V out equals 4 volts, and the voltage at R is equal to 8 volts. Then the resistance R equals 2000 ohms. We can say which is less than the original 20,000. There we go.